Great, thank you. And thanks for the opportunity to come and speak to you guys this afternoon. As you just said, I'm obviously looking after our manufacturing strategy at Autodesk. So what I wanted to do this afternoon was to talk to you about that strategy, help you understand a little bit more about the investments we're making in what we call the future of making things. So as an example, what you can see here is our facility in San Francisco. It's actually based on one of the piers, and you can see that it's a full manufacturing facility. So to the comments that were just made about digital manufacturing, we're very conscious of the fact that to bring a product to market from initial conceptual design through manufacturing requires a deep level of integration of technology right the way across that entire process. The other thing that we're very interested in is creating more opportunities for small to medium-sized businesses to start to play a more prominent role in the manufacturing sector. And there are a number of disruptive trends that we see which actually open that opportunity up further. So most manufacturers traditionally have competed in one of three competencies that set them apart from their competition. They've either tried to differentiate based on productivity, innovation behind the products that they design and develop, or the processes that they use to take those products to market. And whilst that's still true today, what we see is that there are a number of disruptive trends that are affecting the length of time you can enjoy competitive separation. And so our goal is to help manufacturers embrace those disruptive trends and change the way that they develop and manufacture products holistically in a way that's accessible for everyone, from an individual starting up a company for the very first time to a large multinational corporate organization. So that's what I wanted to give you a little insight on to this afternoon. So to start, it's probably good to look at a manufacturer's traditional process. And so most of our customers would treat the manufacturing process as being fairly linear in nature. Now this is a gross oversimplification, but most organizations typically start by identifying some type of market requirement or problem or need that they then solve, and they come up with some sort of concept which will address that need. And then they go through a process of rationalization to make that product profitable to manufacture and sell in the market. Now we call that process design, but it's actually more of a case of 3D documentation and simulation to make sure that things can be effectively manufactured. They then go through a process of production where they actually physically make the product. They then sell that product in the market, and hopefully customers purchase the product, operate it, and then eventually they'll retire it. And that's what most people would call traditional product life cycle. Now, the problem with the traditional product life cycle is that it paints you into a corner as a manufacturer with what we call a fixed product value. So that's the sum of the input costs, the cost of the business transformation process itself, and any margin that you want to retain as a business. So you have a choice here. You can fall back on the traditional forms of separation, try to increase your productivity, do more with less. And if you're successful, you have extra margin. Now you have a choice then as a manufacturer. You can either use that margin to lower the cost of your product, which is risky if you want to avoid becoming a commodity, or you can take the more popular approach these days, which is to pursue a differentiated strategy where you use that extra margin to increase product capabilities and set a brand value that differentiates you from your competition. Now, to do that, we believe that manufacturers need to radically change their approach to that traditional product life cycle. So at the conceptual phase, I think Dr. Kramer actually outlined this perfectly earlier. You'll see that many manufacturers are starting to embrace the concept of personalization. So effectively, in consumer products, that might mean tailoring the product. In industrial machinery, it might mean configuration. But in both cases, what you're trying to do is enrich your product portfolio so it more precisely matches the requirements of your customer, and you can differentiate more and you can effectively charge more. I think the example you showed earlier of the dress is a perfect example. When you move into design, it's all about collaboration. So in the same way that telepresence and GoToMeeting have kind of revolutionized how people meet and do business, so there are manufacturing technologies that will revolutionize how we collaborate together. With the increase in product complexity that we see in the market, there is a more extended design team that needs to operate as though it were co-located, when in fact members of that design team may be in different continents of the world. And so technologies like HoloLens from Microsoft offer us the opportunity to equip people with tools so that they can actually effectively collaborate as though they were in the same room together. And the same is true of using cloud technology to provide a single platform for access to a single source of data. In production, it's about moving to more flexible forms of production. So this could be configurable factories or 3D printing. Now, the point here is that if you're going to truly embrace personalized products, you can only do that if you're able to more flexibly manufacture those products. So instead of the traditional mass production, you move to mass customization. Most of our customers are trying to move away from traditional product sales, and they're moving towards what we call a consumer experience. Now, that experience starts when you help the customer first engage with your brand to configure the product that they might purchase, but it should extend past the point of sale to the point where you can deliver connected services to those products once your customers own them. And again, I think we talked about IoT, and we're certainly making investments in IoT because for the first time, it offers manufacturers the ability to move beyond the fixed product value to start to offer aftermarket services like preventative maintenance or predictive failure. So that increases the opportunity for small to medium-sized businesses to actually derive more revenue from their product designs. And eventually we see customers moving towards product as a service itself. So excellent examples from GE already, where you can, instead of purchasing an aircraft engine, pay for power by the hour. And there are many other manufacturing organizations that see this as an opportunity to start to deliver their products in market as services rather than products themselves. And so our belief is that the further we can help our customers move up to the right, the more lifetime value they can derive from the product designs that they develop and bring to market. Also, if you can connect to your product once it's in the field, for the first time ever, you can move away from that fixed, linear, waterfall product development process, bring the information back into the conceptual phase and move to a more agile, iterative product development process. And that's what we call the future of making things. That's really what we're focused on at Autodesk in manufacturing, is really equipping our customers to help solve the challenges that you see laid out before you there. And so there are 4 key areas that we're focused on. The first in design is around what we call generative design, which I'll show you an example of in a moment. The second in production, and again, I take the point that true digital manufacture is understanding how you're going to put that part into production, is what we call industrial additive, the ability to print in 3D with metals. And once those products are sold, it's about enabling and equipping our customers to connect to those products. But bringing all of this together is a complete solution, a completely integrated solution. So rather than a CAD system and a CAM system and a factory planning system and a data management system that are all separate, we're aiming to achieve a complete solution that we can bring to market. And so to give you a little example of that, I wanted to talk about one particular technology we have, one called Fusion, which will help demonstrate quite nicely what that complete solution looks like. Okay, so what this solution looks like is it completely integrates data management. So if you're working with a distributed design team, everyone can access the same source of information. It has complete collaboration tools that allow traditional processes like redline and markup to happen online with discussion. Industrial design is included for freeform surfacing and styling of products. The ability to be able to move through into detailed parametric design for engineering, visualization, as well as the capabilities to document that design on the cloud with drawings. Included also is the ability to do multi-body FEA analysis, and as well as connected manufacturing systems that will enable you to do things like 3-axis milling so that you can actually cut the chips or 3D print the product, as well as explaining how that product works to your customers, all on a single integrated complete solution that runs on a Mac, on a mobile, or on a PC. So the idea is to do that, is to bring one single technology to market that's much more accessible to everyone. And so that particular technology that you see there is free to students, it's free to hobbyists, it's free to startup organizations that make less than $100,000 a year. And even if you go beyond that, it's only $25 a month, because our view is that this is really table stakes in terms of design and manufacturing technology and should be accessible to everyone. So moving beyond that, we're investing in what we call generative design. So this is an example of a quadcopter here, which doesn't look much like a quadcopter, because what we're actually going to do is use the system to remove unnecessary material until we arrive at an optimum 3D model based on the material that we've selected. Now in this case, it's what we call topological shape optimization, because there's only really one right solution based on those constraints. But of course, as a designer, you often face challenges where there are multiple requirements that you're trying to solve for, such as in the case of this bike, for example, and that can often lead to hundreds, if not millions, of different variants that you could potentially select from. And that's where the cloud comes in, because we're able to combine this technology with simulation, parallelize it on the cloud so that we can solve for hundreds of thousands of variants in parallel, and then provide the designer with a tool that enables them to browse the solution domain. So in this example, what we can do is pivot around requirements like cost, material, weight, manufacturing time, until we arrive at a design that's optimally suited to the market that we're trying to sell this product into. A great example of implementation of this technology is Under Armour, who've just brought the world's first pair of 3D printed shoes to market. You can see the latticing in red there on the sole of the shoe, entirely produced with this type of technology. And again, that type of technology extends into manufacturing with what we call industrial additive, which is where we start to print in metals. And as my colleague from Penn State pointed out earlier, we acquired the pan computing technology to enable us to accurately predict metal-based printing. This example comes from Toyota. It's a cylinder head from an engine, and the latticing that you see on the interior of what would have traditionally been a casting is actually there not only to lightweight the product, but also to control thermal distribution. Now that means that you can run the engine at a higher temperature and a higher pressure. It means it's much more performant and reduces fuel consumption, so it's actually a more efficient engine. This type of technology means that every print can be unique if you need it to be. And so, it will create a huge amount of disruption in those traditional manufacturing markets. And the final example I wanted to share with you was the implementation of IoT technology to connect to products that our customers are actually taking to market. This example comes from a company called TSM, who are able to use IoT technology to connect to their products in the field to not only offer things like preventative maintenance, but also to control the manufacturing process for their customers and thereby enable Industry 4.0. And so that hopefully gives you a flavor for some of the areas that we're invested in.